All right, class. This is lesson 6.5, properties of exponents. Check your understanding. The first question, number 1, A, B, and C, asks you to rewrite each expression as an integer or a fraction without exponents, without a calculator. So do this without a calculator. So you have to remember your properties of exponents. For example, 6 to the negative 2, you should instantly recall that, hey, it's a negative, you have a negative exponent. It's sad. The 6 is sad and depressed. It wants to move. It's at Bullard, and it wants to move to Memorial. And once it moves, it's positive. So it's 1 over 6 squared. And 6 squared is 6 times 6, which is 1 over 36. So 6 to the negative 2 is 1 over 36. Now, in this case, you have 4 times 3 raised to the third power. Distribute the exponent to each. This equals, you have 4 to the third over 4 to the first. When you divide powers, you subtract the exponent. So that becomes 4 squared times 3 to the third. 4 squared is 16, 3 to the third is 27, and then you just multiply 16 and 27 together, and I'll do this in my head. I'm not really, because I'm not that smart. 16 times 27. I carry the 2, 3. Okay, so it's 432. So as a fraction without exponents, without a calculator. So this becomes, okay, I see. So 16 times 27 is equal numerically to 432. Okay? I would have been happy if you had left it like this, because I don't want you to use a calculator. This unit, or at least this lesson, the stuff we're doing here, I'm not really going to let you have a calculator to use. You're going to have to do it sans calculator. So I'm going to expect you to leave it like this, basically. 4 squared times 3 to the third. All right, but if you have a calculator, you know 4 squared is 16, 3 to the third is 27, and you can multiply and you get 432. Now, 5 squared times 7 to the fourth, you got 2 ways of looking at this. One way is that this exponent gets, it's a product inside, so you can write that as 5 to the 2 times 0 and 7 to the 4 times 0. This becomes 5 to the 0 times 7 to the 0. And each one's 1, so that equals 1. Or you could just have stopped and said, wait a second, this whole thing inside the parentheses right here, this thing, is raised to the 0 power. So this is the base. So this is the base raised to the 0 power, and you can instantly have written, well, that's just 1. Okay? Now, here's the beginning of us dealing with these properties of exponents. Rewrite each expression as a single term with a single exponent. So in this case, notice the power of 4 is only attached to the d to the 6th. When you raise a power to a power, we multiply the exponent. So that's going to be 3 times d to the 6 times 4 power. 6 times 4 is 24. So this is 3d to the 24th power. And that's the answer. Okay, let me shrink this down just a smidge, because I blew it up so you can read this. Okay, now, and that was what it was before. Notice the 3 just came along for the ride because the exponent was not attached to it. It was only attached to this. This 3 does not have that 4 on it. It's only the d to the 6th power that does. All right? On this case, what I tell my students is simplify the top and the bottom if it can be simplified. In other words, I would go w to the 4th times w to the 5th and write that as w to the 4 plus 5 power over 3w to the 6th. Now, 4 plus 5 is 9. So this is 9w to the 9th power over 3w to the 6th. Now, here's the deal. Just because we learned about exponents, it does not change the fact that when you have 9 divided by 3, that simplifies. So those are numbers. That simplifies simply to 3. So we end up with 3. Now, the w to the 9th over w to the 6th becomes w to the 9 minus 6 power, which equals 3 to the w to the 3rd power. And that's the fully simplified version of b. These are equivalent statements. All right? The one I circle is just a lot prettier, and it's not as ugly. All right. On C, now we have two things multiplied. And when you have this, what I tell students is first, you can rewrite this and put the 4 times 5 in front, because you can change the order of multiplication. And then right behind it, g squared times g. Okay? I just rearranged this. Now, you don't have to show this, but this is what I'm doing. So I know what 4 times 5 is. I know that's 20. And now here's where kids get hung up a little bit. When they see g squared times g, they'll write g squared. But remember, when you just have a variable, like this g that's by itself, right? I'm sorry. That this g right here has no exponent. Put a little 1 on it to remind you, hey, the variable has a hidden 1. So now we add the exponent. So that becomes g to the 2 plus 1. And we end up with this result of 20g to the 3rd power. And that is what C is simplified. All right? And those were those problems. Oh, sorry. Okay. Now, find the exponent value that makes each equation true. 3 sevenths raised to the x power equals 9. Well, the first thought that comes to my mind is I should think of 9 as 3 squared, and 49, isn't that 7 squared? So if you see this, 3 over 7 to the x power is said to be, is equivalent to 3 squared over 7 squared. So that means x must be equal to 2. So we found the exponent. Okay. 2 to the x equals 1 over 8. Well, 8 is 1 over 8 is 1 over 2 to the 3rd power. And I know I can move exponents. I can move these powers around up and down by switching the sign of the exponent. So I'm going to move this 2 to the 3rd to the top. And this becomes 2 to the negative 3 because I moved it upstairs. Now you have this, 2 to the x equals 2 to the negative 3. Well, obviously, I can't even talk. Obviously, x must equal negative 3 because the bases are the same. They both have 2. So we just equate the exponents. All right? C, 5 times 4 to the x power equals 5. Well, remember, don't let this freak you out because 5 is the same thing as saying 5 times 1, right? 5 times 1 is 5. And 1 can be thought of as 5 times 1 can be thought as 5 times. Now 1 can also be thought of as 4 to the 0 power because that's also 1. So that tells you x must equal 0 because 4 to the 0 is 1. All right? And that's how you can do that problem. And there you go. And that was check your understanding. Have a good day.